there are many options to reduce emissions and to achieve relatively low stabilisation levels. Energy efficiency, carbon capture and storage combined with the usage of fossil fuels, renewable energies, nuclear power, biomass also combined with carbon capture and storage are the most viable options. And these options will be discussed extensively now in the scientific community. So the scientific community tries to find out what are the costs, the risks and the benefits of these options.
Often we talked about global perspectives, and one forgets that actually decisions are made locally, and it's regional perspectives that in many ways are more important. So I would characterize that as a bottom-up view of the world. Now, let me just first say that there are things that are in common, despite the huge diversity. The things that are in common that we have concluded in the global energy assessment is that improving the efficiency at all scales, from production all the way to end use and consumption of energy, that those efficiencies are the most important measure that enables many other characteristics of the transformation. The second one would be a more important role of the carbon neutral technology, such as renewables. They also improve the security and can reduce air pollution and other environmental problems.
Carbon capture and storage is seeing very little progresses. So, for example, in our scenarios, by 2035, we see up to 3 gigaton of CO2 emissions being abated through these options. So carbon capture and storage applied to power generation sector and to industry. The reality is that today, in 2011, we are storing and capturing 32 million tons. So in front of us, over the next 20-25 years, we have to scale up by factor of 100 times what is happening today. This is a technology that is not proven at large scale yet, and in the absence of a global carbon price, is proved very difficult for industry to start investing in it because they don't see any interest in doing so.
Now, the IPCC has published a report last year where the IPCC tries to explore the potential role of renewables. And it is quite interesting to see that we evaluated more than 164 scenarios. And in all the scenarios, renewables play an important role, but the role is quite differentiated. Some scenarios combine renewables with nuclear power and carbon capture and storage. Some of the scenarios indicated that renewables play the most important role, even beyond 60%. So there is a broad range of options to use renewables.
So we're now a year away from the Fukushima accidents. It's still unclear, but I think the dust will settle, sooner rather than later. I guess in the next 2 to 5 years, I would imagine. I think we will have a much better picture because that's typically the time frame you need to really kind of orient your energy R&D and policy. Nuclear would have had a difficult time to really become a major player globally with or without the Fukushima accidents for many different reasons. I think now it's clearer than ever. I think that nuclear will play a more kind of a smaller role that many had anticipated before the accidents.
Now, in the previous assessment reports, we have explored also the costs of the different mitigation options, but we have explored the costs under a very important assumption. And the assumption was that all the technologies are available at the right time when they are needed. In this assessment report, what we are doing, we try to find out what happens with the costs of mitigation when there is a limited availability of technologies like carbon capture and storage, like nuclear power. You know that in Europe, but in other parts of the world, the social acceptability of this kind of technologies is under a public debate, and so there might be some delay in deploy this kind of options, and even in the sector of the renewable energies. So the most advanced technologies like biomass plus CCS might be available only in a delayed perspective. And therefore, here we need a careful analysis what happens with the mitigation costs when we have a limited availability of technologies. This is, from my point of view, one of the most important challenges.